All right, here are the notes for 7.5. We're solving more trig equations, so we're just going to continue to solve trig equations as we did in 7.4. So the first one says solve the following equation for theta is in between 0 and 2 pi of cosine of theta over 2 plus root 3 equals 0. So I'm going to do the same thing I did if it was a double angle. I'm going to do u substitution. So u equals theta over 2, and you get 2 cosine u, not u, 2 cosine u plus root 3 equals 0. So cosine of u equals negative root 3 over 2. So u equals, so where's your cosine negative root 3 over 2, right? We're going to come over here and draw a triangle, and cosine is negative in the second and the fourth quadrant, so it's right here and right here. That's where your x is negative root 3 over 2. So we get 5 pi over 6 plus 2 pi k. So again, we need to write the 2 pi k to see if we need to use it again. Or to see if we can do more than just the angle that we have inside our domain. And then you have 7 pi over 6 plus 2 pi k. So now we have to substitute the theta over 2 in for u. So you get theta over 2 equals 5 pi over 6 plus 2 pi k. Multiply everything by 2 to get theta by itself. So you get theta equals, this will be 5 pi over 3 plus 4 pi k. So that's obviously too big. It can't be plus 4 pi k. So 5 pi over 3, it's less than 2 pi, so that one works. So here's one answer. And then we'll do it again. Theta over 2 equals 7 pi over 6 plus 2 pi k. Cool, I got triangles. All right, plus 2 pi k. Multiply both sides by 2. Oh my gosh. I don't know why it's doing that, but whatever. Theta equals 7 pi over 3 plus 4 pi k. Okay, clearly we don't need the plus 4 pi k. That's too big. But 7 over 3 is bigger than 2 also, so that one doesn't work either. So the only solution to this problem is 5 pi over 3. That's inside our domain right here. All right, the next one, solve sine 2 theta equals 2 cosine theta. For this one, I'm not going to use u substitution yet because sine 2 theta, if I do sine u equals 2 cosine u, I'm not really sure where that's going to happen. So I'm going to start by using the double angle formula. So you just kind of have to think about what's going to work out, or try something, and if it doesn't work, try something else. So sine of 2 theta is 2 sine theta cosine theta. So you have sine 2 theta cosine theta, 2 sine theta cosine theta equals 2 cosine theta. And remember from yesterday, you can't divide by a variable to solve an equation. You have to subtract it over. So I have 2 sine theta cosine theta minus 2 cosine theta equals 0. Factor out the cosine theta, and you're left with 2 sine theta minus 2 equals 0. I guess we could have factored out the 2 also, but either way, it doesn't matter. Then you get cosine theta equals 0, or 2 sine theta minus 2 equals 0. So we'll come over here and do our little unit circle. When is our cosine 0? So the cosine is 0 when your x is 0. So it's right here and right here, right? So you get theta equals pi over 2 plus pi k, because it's here and then here and then here and then here, right? So we only need to add pi k. And then sine theta, or 2 sine theta equals what? 2. So sine theta equals 1. Where's your sine 1? Well, my sine is 1 at pi over 2 plus pi k. But that's already included in the solution, so we already have it, or plus 2 pi k. So we already have it, so that's just your only answer. The pi over 2 plus pi k will take care of both of those situations. Okay, our next problem, if you have a cosine squared and a sine not squared, so if you have two different trig functions and one of them's squared and one of them's not, you want to change the one that's squared into the one that's not squared. So we have, remember, we have sine squared plus cosine squared equals 1. So we could rewrite this cosine squared as 1 minus sine squared. So you have 1 plus sine x equals 2 times 1 minus sine squared x. So the reason why I want to do that is because I can't factor something that has a cosine squared and a sine to the first power. It doesn't work. Those are not the same functions. That would be like having a y squared and an x that you're trying to factor, and that just doesn't work. So distribute your 2, move everything over. You have 1 plus sine x equals 2 minus 2 sine squared x. Move it all over, so you get 2 sine squared x plus sine x minus 1 equals 0. It's quadratic. Now we can factor it. So 2 sine x and sine x. Again, if you can't figure out how to factor it with the sine, come over here and do it and factor just a regular quadratic. So 2x and x, and then those are both 1s. And then we want it to end up being positive, so this has to be the positive value, right? So this has to be the plus, and that's the minus. So you have 2 sine x minus 1 and sine x plus 1 equals 0. And then you can set each equal to 0 and solve. So 2 sine x minus 1 equals 0. Sine x equals 1/2. And then sine x equals negative 1. Oh, sine x plus 1 equals 0. So sine x equals negative 1. All right. On my unit circle, sine is 1/2 right here and right here. So x equals pi over 6. Pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k. I hope you guys are remembering your unit circle because you're really going to need it. And then sine is negative 1 right here, so x is also going to equal, move it up a little bit, x is also going to equal 3 pi over 2 plus 2 pi k. So those are all my solutions for x. All right, just have a couple more examples. This is a fast lesson today, so I should be able to get it all in this video. Okay, you have cosine x plus 1 equals sine x. All right, so the identity properties, the sine squared plus cosine squared equals 1, only works when they're squared, and nothing is squared right now. So how do I solve when you have a cosine and a sine and nothing's squared? Well, one way to solve an equation is to square both sides, right? That's a valid way to solve an equation. So I have to FOIL the cosine x plus 1, so I get cosine squared x plus 2 cosine x plus 1 equals sine squared x. So remember that I said if you have one of them that's squared and one of them that's not squared, you want to change the one that's not squared into the one that's squared, just like we did before. So this sine squared needs to be 1 minus cosine squared. So you have cosine squared x plus 2 cosine x plus 1 equals 1 minus sine squared cosine squared x. Move it over. So I have 2 cosine squared x. Okay, you have 2 cosine squared x plus 2 cosine x equals 0. So factor out a 2 cosine x, and you get cosine x plus 1 equals 0. So set them each equal. 2 cosine x equals 0, and cosine x plus 1 equals 0. So cosine x equals 0, and cosine x equals negative 1. So your cosine is 0 right here and right here, right? So x equals pi over 2 plus pi k. And then your cosine is negative 1 right here, so x equals pi plus 2 pi k. Now, those are the answers that I got, but to solve this equation, I squared both sides. So if you square both sides of an equation, that could introduce extraneous solutions. Remember those? So check your answers in original equation. So we're going to plug them in. So I have pi over 2. So I have cosine of pi over 2 plus 1 equals sine of pi over 2. Cosine of pi over 2 is 0. 0 plus 1 equals 1. That one works. I also have to check 3 pi over 2 because I'm saying that it's plus pi k. So I'm saying it happens on the top and on the bottom. So cosine of 3 pi over 2 plus 1 equals sine of 3 pi over 2. So the cosine of 3 pi over 2 is negative 0, 0 plus 1 equals negative 1. That doesn't work, right? So we need to fix this one. And then let's try the last one. Cosine of pi plus 1 equals sine of pi. So cosine of pi is negative 1 plus 1 equals sine of pi, which is 0. That works. So our solutions are actually x equals pi over 2 plus 2 pi k, because that one down here didn't work, so you can only go all the way around the circle every time. And then pi plus 2 pi k. So those are the solutions for that one. Okay, I'm going to stop this video here because I don't know if I'll have time to do the last one, and then I'll do another video for the last problem. So